Fire is one of the most familiar things we know, but in space it behaves in ways that seem almost impossible. On Earth, flames rise because hot air moves upward and cold air rushes in to replace it. That's what makes fire flicker. But in zero gravity, that doesn't happen. There's no up, no down, and no direction for heat to move. Without gravity, flames don't rise. They float. They become soft, glowing spheres, hovering like tiny suns. Astronauts were amazed when they first saw this. A perfect orb of fire just hanging in space, calm and silent. Without convection, there's no flicker, no smoke trail, just a small, steady glow of blue. NASA scientists have been studying this strange behavior for decades aboard the International Space Station. They run experiments called FLEX, the Flame Extinguishment Experiment, where astronauts ignite small fuel droplets. In these tests, they discovered something truly unexpected. When a normal flame goes out, a new one can quietly keep burning. This invisible reaction is known as a cool flame. Cool flames burn at much lower temperatures, only a few hundred degrees Celsius. They don't shine brightly, but the chemistry continues. In fact, a cool flame can keep consuming fuel without producing light, almost like fire's ghost. Here on Earth, gravity and air currents make these flames unstable. They appear for milliseconds and vanish. But in space, cool flames are smooth and steady. They hover in perfect balance, letting scientists watch every detail. These discoveries could revolutionize how we understand combustion, and maybe even how we power engines in the future. Imagine cleaner engines, spacecraft propulsion, or even sustainable energy, all inspired by flames in zero gravity. But studying fire in space also comes with danger. Without gravity, smoke and heat don't rise. They just float. That means even a small spark could fill a spacecraft with toxic fumes in seconds. That's why every flame experiment aboard the ISS happens under strict control inside sealed glass chambers. For astronauts, every spark is both beauty and risk. Still, they keep studying it, because every flame tells a story about how nature behaves when you remove gravity. It's a story about chemistry, physics, and the resilience of energy itself. And beyond science, there's something poetic about it. Fire, so familiar on Earth, transforms into something alien in space, a calm, floating sphere. No sound, no direction, just light, softly suspended in silence. It's like watching the essence of fire stripped down to its purest form. Cool flames remind us that even the simplest things can reveal new mysteries when we see them differently. They show that science isn't just about control, it's about curiosity. Each flame experiment in orbit brings us closer to understanding how energy works across the universe. And what we learn up there could help us down here. From efficient engines to cleaner fuels, from ancient torches to rocket thrusters, fire has always followed us. Even in space, it adapts, changing shape, temperature, and color, but never disappearing. It's a symbol of life and discovery, reminding us that energy finds a way to survive anywhere, even in the cold vacuum of space. So next time you light a candle, imagine what it would look like in orbit, a tiny blue sun floating silently before your eyes. Cool flames aren't just science, they're living art, proof that the universe still has secrets left to share. If you loved this journey into the strange beauty of space fire, subscribe for more. There's so much more to explore, and this is only the beginning.